Hello, this is a demonstration of the code shared on this GitHub repository. I have already cloned the repository to my local folder. Let's have a look at its contents. This is the folder containing the time-lapse images. I am using only 40 images for this demo. And this is the destination folder. Outputs from 2 previous analyses are already here. Let's move on to the next item, the YAML file, which is used to configure the code for specific scenarios. You can see the destination path here. This is where the output files will be saved. If you need a detailed output of the analysis, set this to true. There are also several other parameters that can be tuned. For details, please refer to the paper cited in the repository. This file contains the functions called by the main script. Now, let's take a look at the main script. This is the path to the source directory, currently hard-coded to this folder. To select the source interactively, enable this line and disable the above one. Let's go ahead and run the main script. First, I need to activate the virtual environment. Next, I'll move to the clone directory and run the script. The initial just-in-time compilation, using number, may take some time. Meanwhile, let's open the destination folder. The compilation is now complete, and the code is prompting me to select an axon. I'm selecting this axon using mouse clicks. If needed, you can right-click to remove all selected points. Now, press any key to continue. You can see that the code is now iterating through all the images, and a new folder has appeared in the destination path. The script has finished execution. Let's check the contents of the output folder. You can find 3.txt files here. Let's open the file beadcords.txt. This shows the coordinates of the confirmed beads in each frame for the selected axon. Here, we can see that beading has started from frame number 13 onwards. Moving on to the file bead parameters, it contains the details of all the suspected beads that underwent rigorous analysis. Now, let's move to the file rigorous bead analysis. For each suspected bead, it confirms whether it was identified as a bead or not, along with the reason if it was rejected. Now, let's quickly see how these output data and files can be utilized. Consider frame number 15. The file shows that 2 beads were detected. This should be shown in the rigorous bead analysis file. Now let's view these beads, labeled as I equals 0 and I equals 1. Both the cropped bead and its detected edges, along with the masks used, can be seen here. Now let's look at the case k equals 14. And I equals 0, where a structure was rejected to be a bead. When you look at the edges, it can be seen that there is no bead-like swelling on the edges. Also, for each frame there is an interactive HTML file. The user can interact with it, see the coordinates of the features, zoom into the edges, etc. There is also a plot of the diameter along the axon, which allows the user to see the peaks, their coordinates, and other related details. Hope you found this demo useful. Thanks for watching.